Yes, today we will discuss about the non-deterministic finite automata. So last class we have discussed about the deterministic finite automata. That means for a particular input symbol, we have a single transition. Like for suppose we will take the input symbol, small a. The next symbol that we have to take other than small a. That means we can take any input symbol. So the particular state, the particular input symbol has to be unique in the deterministic finite automata. Now coming to the NFA. From any state, the particular input symbol may be any combination to all the states. That means, so from Q0 to we have given the input symbol as A. Again from Q0 to we have given the input symbol as small a. So the same input symbol we can give to many transitions in the NFA. Coming to the DFA, the particular input symbol that will be unique in the transitions. That is the DFA and the NFA differences. Now coming to the formal definition of the NFA, it consists of the 5 tuples Q0, summation, delta, Q0 and F. So Q means set of alphabets, set of states like, so in our NFA we have Q0 comma Q1. Next, summation means input alphabets. In our NFA we have the single input alphabet, that is the small a. Coming to the transition function, so NFA means from the set of states, we have the many input alphabets, that means we have given it as the 2 power q. Whereas in the DFA, we have the transition function is delta equals to q into summation that applies to q itself. That means, so whereas in the DFA, from a particular input alphabet, so that means we have the single transition to q. So coming to the NFA, we have the many combination of the states, that is the NFA. So we will see the definitions. Coming to the Q0, Q0 is the initial state. So F is the final state. Same like DFA, but the NFA, the transition function is different. So it has 5 tuples, Q, summation, delta, Q0 and F. Q is the set of states, whereas summation is the input alphabets, delta is the transition function, Q0 is the initial state and F is the final state. The transition function is different to both DFA and the NFA, remaining all the tuples are same. Next, we will discuss with some examples how to construct NFA and so on. So we have, for suppose we have to construct NFA with some input alphabets A comma B and some states like Q0 comma Q1. So we have to construct DFA, that we have to design the DFA, so design the NFA. So the right to the most symbol is, second symbol is B. Right to the second symbol is B. So first we will take the initial state. So right means this is the right side. Right to the second symbol is B. So that means we have to design the NFA. The right to the second symbol is B. That means right to the first symbol is maybe anything, either A comma B. Right to the first symbol is B. That means, so the initial that starts from either A comma B. So whereas we seen in the DFA that we have the single, the particular input alphabet B, we have the single transition. Now, when we observe in the NFA, for the particular input alphabet, that is the B, we have the two transitions from Q0 to Q0 as well as Q0 to Q1. Like that, we will draw the NFA. There is no conditions for the transition in the NFA. Next, we will go with the one more example. So, construct NFA. That accepts the string double ones followed by double zero. Double ones followed by double zero. That means we are taking the states. So how we have to take the states? First, the input string is, the length of the input string is 4. So 1 1 0 0, the length of the input string is 4. The number of states that we have to take is 4 plus 1. That is, the total states we have to take is 5. So Q0, Q1, Q2, Q3 and Q4, that is the final state we have to take. So the number of states we will get is length of string plus 1. So length of string is 4. 4 plus 1 is 5. So now the given condition is double ones followed by double zero. So that means double one followed by double zero. So Q0 is the initial state that we have start from the double one, that is followed by double zero. That means this is the end state. Now, according to the NFA, we have to give the transitions. So double ones followed by double zero that we have. So that means, whereas in the starting states, maybe either 0 or 1. As this is the NFA, already I have given Q0 to Q1, that is the one input alphabet. So whereas there is no condition in the NFA, again I am giving Q0 to, so the self loop 1. Double one followed by double zero, the may be starting either 0 or 1, no problem. At the end also, either 0 or 1, there is no problem. So that means the strings that you can accept 1 1 0 0 1 or maybe 0 1 1 0 0 0 or 0 1 1 0 0 1. The thing is, double one has to follow double zero. The starting and end of the symbol is anything. So that I have given it as 0, 1 for the initial state and again 0, 1 for the final state. So that means any number of ones or zeros for the starting and the ending, but in middle it has to follow the condition like double ones followed by double zero, like that. So we will go with one more example here. For suppose we have to construct NFA. So here we have taken the digits, right? So here I am taking the characters. We have to construct the NFA that has to accept the string ing. That means so ing, the length of string is 3. So that means the number of states is 4. So we have to start from the initial state. So arrow that indicates the initial state. So the condition is it has to accept the any string that is with ing. So I am writing simply as ing. That means the initial that starts from the any type of the character. So simply we can write it as from A to Z, and also at the end you can simply write it as A to Z. For suppose the same question that will ask end with ing, what we have to do? End with ing means we should not give this transition. So for suppose, so it has to follow ing means we can give the transition. For suppose it has to end with ing, should not give the transition at the final state. So for suppose the question asks same, the starts with ing means what we have to do? We have to remove this from the initial state. It has start from with ing. At the end maybe any characters. So you can give it as A to Z. Starts with ing means you have to give with start ing and any number of characters. So for suppose end with ing means for the initial state you have to give any number of characters like A to Z and end with ing. So like that we have to construct our NFA. So these are the construction of NFA. Now we will move into the different types of the NFAs. So up to now, whereas in the finite automata we have seen DFA, that is deterministic finite automata, and we have seen NFA, that is non-deterministic finite automata. Come to the one more version of NFA, we have NFA with epsilon closure. That means NFA that satisfies the epsilons, but coming to the DFA that doesn't satisfy any epsilon here. NFA satisfies the epsilon, that means we have one more version with NFA, that is NFA with epsilon closure. First we will see what is epsilon closure. So we will take one example. So always I am taking Q0, Q1, Q2 are the initial state. Here you can also take any states, like here I have taken A, B, C. So we will see the epsilon in the transition. So whenever we will got epsilon in the transition, that is the NFA only. Whereas in the DFA we won't get any epsilons. That we have to remember here. So this is the NFA. So for this we have to find the epsilon closures. So first we have to find the epsilon closures for all the states that are given in the NFA. Here the states that are given in the NFA are capital A, B, C. We have to find the epsilon closures for all the states. So first we will go with the epsilon closure of capital A, epsilon closure of capital B, epsilon closure of capital C. So first we remember that whenever we are finding the epsilon closure, the same states that itself will get the resultant to the epsilon closure. That means, so epsilon closure of capital A, the same state itself. Now in the name itself we have epsilon closure. That means whenever we are moving the transition through the epsilon, so see from the capital A, we are moving through the epsilon, we are moving to the B, and we are moving from B to C through the epsilon, right? So from A to, you can move B through the epsilon. From B to C through the epsilon, we can also move to C. From C, so there is no epsilon to any state, so we will stop this. Next, coming to the epsilon closure of B. First, the same state itself, that means finding for the B. So we will let for the B. From B, where we are moving through the epsilon, from B we are moving to the C. And from C, we don't have any epsilon transition, so we will stop here. Next, coming to the epsilon closure of C. Don't forget this, for the same state, we will give the same resultant. So for identifying for the C, the same state C itself, and we don't have any epsilon transition from the C, so stop it. Like that we have to identify the epsilon closure of for all the state like A, B and C. So once again remember that epsilon closure of A means the same state itself, epsilon closure of B means again the same state, epsilon closure of C means the same state. So coming to the epsilon closure of A, so from A we can move A to B with the epsilon transition. So I am writing B. From B to C, again moving to the epsilon transition to the C. From C we are not moving anywhere, so we have stopped it. Next, coming to the epsilon closure of B, from B we are moving to the C itself. So from C we don't have any epsilon transition. From C we don't have any transition, so we have stopped this. So first identifying the epsilon closure, that is very important. whenever we have to conversion of NFA with epsilon and NFA epsilon to NFA and so on. So that is very important.